Hey guys, so today is going to be the last set of notes. I thought we were going to end at lesson 2, but we're going to go to lesson 3, and we're going to talk about figuring out surface area of a rectangular prism. So that's the only one that we're going to do on. We're not going to do one with triangular prisms. We could, but we're not going to. Okay? Of a rectangular prism. How about prism? There we go. That makes more sense. So let's talk about what on earth do I mean by surface area. Well, think logically about the words. Surface, area. Or switch them around, area of a surface. So when we're talking about surface area of a prism, we're talking about the sum of the areas of all three-dimensional figures, or three-dimensional figures, faces, or, spelled out all the way, surfaces. So each of the flat parts of our rectangular prism is called a surface, and if we figure out the area of each of them, there we go, okay? So let's kind of make sure that we understand. Oh, you know, I wanted to throw this word in. I think I forgot to put it in before, but it will show up if you watch like a con video that I've put up there for you guys to watch if you want to. Polyhedron. Polyhedron is the same thing as a polygon. So it's a three-dimensional figure with edges. So this eliminates, by definition, it wouldn't include anything that had curves to it, like a cylinder or a cone, okay? All right, so let's just kind of look at a rectangular prism. Boom, boom, boom. I like how I make my noises when I'm drawing my figures. Yeah, I know. I'm kind of weird like that. So we have 4 inches by 2 inches by 3 inches. So what do we know about a rectangular prism? Rectangular prism. Now, if you didn't get it through my last video, I'm just going to beat you over the head with it again. Remember, all the sides of a prism, all the sides, not the bases, but all the sides of all prisms are rectangles. But what makes a rectangular prism even more interesting is that all of the surfaces are rectangles, okay? So how many surfaces does a rectangular prism have? Well, it has 6 faces. Now, faces is just a short way of saying surfaces. Surfaces, get it? Now, what's interesting, and we talked about this before, is that there's going to be 3 unique, it could be less, dimensions. Well, and remember sometimes, and what I mean by unique, I'm talking about length, width, height of the prism. But because I only have 3 numbers, then there's only 3 ways to organize those numbers together. So that means we're going to create 3 unique areas. Now, again, the word unique means different from the rest. However, that could be not necessarily the case because we could have 2 of the dimensions could be the same number, or in the case of a cube, all 3 of them would be the same. Okay? So remember how we talked about this before? We have a top and a bottom. So in this particular place, the area would be 4 times 2, which would be 8 square inches. And then we have a front and a back. And in this particular example, the front would be a 4 by 3. which would give me 12 square inches. And our left and right sides, that would give us a 2 by 3, or 6 square inches. Now, that's only for the 3 we see, but the 3 we don't see match up one of these guys. So that means we're going to get 2 that have an area of 8. So both the top and the bottom have an area of 8 square inches. We're going to get 2. Oh, that looks really bad. Sorry. Didn't give myself a whole lot of room to write. We're going to get 2 that are 12 square inches because we have a front and a back that match. And then we're going to get 2 surfaces that are 6 square inches because we have a left side and a right side with the same dimensions. Now, what some people like to do is to draw out their figure, and they use something called a net. So I'm not talking about the thing you catch butterflies in. I'm talking about what happens when you take that three-dimensional shape and you just like cut it on one end and unfold it out, okay? So it's a two-dimensional representation of a three-dimensional figure. Okay, and it helps you visualize or to see, helps you visualize all faces of a figure. So you can calculate the area of each face more easily. Helps if I spell correctly. Now, how do I go from the net to surface area? Well, I take all of those surfaces I just calculated area of, add them up, and then I've got surface area. So what I'm going to do is I'm going to take that particular shape that we'd already drawn, and I'm going to draw the net for that guy, okay? So we're going to have... Oops, that's a little too big. So if you just heard that noise, Tiana's in the room with me. Okay, that's a terrible drawing. Let's try that again. Maybe get it right on the line. That would be helpful. Unique. Okay. So basically what I did is if you look at the front of your shape, so the front of the original shape is this guy right here. Oops. Learn how to spell. Now remember what the front is. It's 4 inches by 3 inches. Okay. Now every line that's the same as the 4-inch is 4 inches. Okay. Now, not all the lines are 3 inches, right? Because 3 just is that kind of intermediate. And remember, the front is not attached to the back. In fact, it's separated from the back. So the front and the back are separated from another piece. Okay, and that piece that's separated from is the bottom and the top. So this is your bottom. I wish I could, maybe I'll just write it vertically. And that would make this guy the top. Okay, so we had the front was a 4x3, the bottom is a 4, but if we look, what makes the bottom is a 4x2. Oh, there's my kitty cat making noise. Okay, and then we have the sides. So I'm going to put 2 is also here. We got 2 there. Okay, and those sides, I'm just going to signify them as being left and right. Now, I did not do a super good job at this drawing because these 2 sides should be the same length. Okay, so they're going to be 3. So anything that touches something else has to match. Okay, so this and this would be the same. This and this would be the same. So this is 3, 3, 3, 3. Does that make sense? And then over here, the same thing. So 3, 3. It doesn't always look like it's matching. So when I figure out the area, just like I did before, I talked about the top and the bottom, the front and the back, the side and the side, left side and right side. And you can see how this looks. Okay, you can see what the net allows me to do. So a lot of people just go ahead and calculate area from the net. So they look at the front and the back. So there's going to be 2 of them. And the area, excuse me, is going to be calculated with 4 times 3. Okay, so that's going to give us 2 times 12, and that's going to give us a total of 24 square inches for those 2 areas. Now if I look at the bottom and the top, or top and bottom, let's do top and bottom. I have obviously 2 figures. And those dimensions are 4, but this time by 2. Shh. Sorry, T's making noise. So that gives me 2, and 4 times 2 is 8. So 2 times 8, and that's going to give me 16 square inches for both the top and the bottom. And then I have my left and right sides. And obviously there's 2 of them, right? A left side and a right side. And the dimensions are a 2 by 3. Oh, I think my neighbor's doing some work in their house. Can you hear that? Zoop, 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 zoop. 2 by 3. Sorry, 2 times 3 is 6. Yeah, I know my math. Good math teacher. So I get 12 square inches for the left and right sides. Now, if I want to figure out surface area, I'm going to put in parentheses SA. I just add these up. So I get 10 and 2 is 12. I get 3, 4, 5. So I get 52 square inches. And that's going to be the surface area of my shape. Okay? Now, I am going to show you a slightly different way of thinking about this. So I'm going to kind of put it off. And these, if I was figuring out volume, I have a 4 by 3 by 2, and it doesn't matter the order of those. So here's what I'm going to do. I'm going to pair up the shapes that, or the numbers, in the 3 unique ways you can pair up 3 numbers. So I'm going to get 2, and I'm going to multiply it by 4 times 3. So I'm going to take the first 2 numbers. Okay. Now I'm going to get 2, and I'm going to multiply it by pairing up 4, but I'm going to multiply it by the other number, 2. Okay. And then I'm going to get 2 shapes, and I'm going to take the last 2 numbers, and I'm going to multiply 3 times 2. So all I did was I pair up the 4 with the 3, the 4 with the 2, and then the 3 with the 2. That's another way of doing it, so don't even need to draw a net. And frankly, I like to not draw the net. That just seems to be longer. I like to cut to the chase, right? So we're back with the same thing we had before. Well, let me do it over here. We have 2 times 12. We have 2 times 8. We have 2 times 6. So we have 24, and 16, and 12. And when we add those all up, we get the 52. So we get, again, 52 square inches. So there's all sorts of different ways to put these together. So looking just at the dimensions, that's how I could put this together. All right, so we're going to do 2 examples. One, you're going to get a net. And the second one, you are going to get just a regular shape, and we're going to just rearrange those dimensions in order to figure out the answer. Okay? So let's start with the directions. Are going to say, find the surface area of each rectangular prism. So the first one we're going to have is a net. Honestly. So this guy is going to be 7 meters by 6 meters. The next one is going to be 7 meters by 8 meters. And then the next one is going to be 7 by 6. And then we're going to have another 7 by 8. I don't know why my shape is tilting, but it totally is. Oh well. And then we're going to have one that is an 8 meters by a 6 meters. Remember how I talked about sides that match up are connected to each other in an L shape? When I fold up, they have to be the same size because they're going to be folding up with each other. Okay. And then I have the other side. And so that's going to be 8 meters and 6 meters. So this is what I'm given. So what I'm going to do is to figure out what area each of those pieces would be. So this guy would be a 7 by 6. Off to the left, this guy would be an 8 by 6. In the center, this guy would be a 7 by 8. To the right, I have an 8 by 6. And then I have a 7 by 6. And then the last one would be a 7 by 8. Okay? So I'm going to take those, we'll start with the 7 by 6. And that's going to equal 42. But I have 2 of them. Right? Because I've got the one that's on the top and the one that's in the 3rd spot. And so that gives me a total of 84, in this case would be square meters. And then I have 2 sides. One of them is 8 by 6, which is 48. But then I'm going to get 2 of them. And that's going to give me 96 square meters. And then I'm going to have the last one, which is 7 by 8. Can you hear the airplanes? I swear it is never quiet around this joint. Times 2, and that's going to give me 112 square meters. So now if I want to do surface area, I'm going to add these all up. So I get 10 and 2 is 12. I get 10, 18, 19. I get 292, and the label stays squared centimeters. So that's how I could figure out the surface area if I had it given to me as a net, or if I wanted to break it down into a net. Now, frankly, I would only do it by a net if they gave it to me. Let's do one that looks more like what we're used to seeing. And we're going to use just the dimensions to help us with this one. Superman vision, so we can see through. And then we've got 7 centimeters by 5 centimeters by 3 centimeters. Okay. So again, we've got 7 by 5 by 3. So what I'm going to do is I'm going to pair them up by 2 numbers at a time. Now there's only 3 ways to put those numbers together. Okay, first way, let's put the 7 and the 5 together. Okay, so I get 7 times 5 equals 35. But I have 2 of those. Okay, so the 7 and the 5 would be the bottom and the top. And that would get me 70 squared centimeters. Next, I'm going to pair up the 7 with the 3. And that's going to give me 21, but I have 2 of those. So that gives me 42 squared centimeters. And then my final way is to pair up the 5 and the 3. So if you think about it, these 2 get paired up together, okay? And that's going to give me 15, but again, I have 2 surfaces that have the same dimensions. That's what's great about rectangular prisms. And we get 30 squared centimeters. So if I want to figure out the surface area, I get 2, 11, 12, 13, 14. So I get 142 squared centimeters. So those are 2 ways to do surface area. And enjoy this, guys. We'll talk to you soon. Bye-bye now.